Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're going to talk about fixing global warming gradually part 9. Here we're going to specifically focus on fuel. So let's dive deep into it. Now, why do we need fuel? Why can't we just run on batteries or things of that nature? Well, reality is fuel is two-part component, meaning you have one half and atmosphere is the other half. So meaning you only are carrying half of it. Fundamentally, that means you have always has much higher energy density than a system that carries both part in itself, like a battery or explosives. And yes, explosives have less power than basically your fuel. And the only reason explosives go boom is simply because it can dump all that energy very quickly. It's a matter of temporal compression. So fuel is flat out better than any cells. It does not matter which chemistry you're talking about. That's like fact, done, go home. So what is our need? Well, our world needs high power, as in like serious amounts of kilowatt, as in you could be talking about 100 kilowatts of continuous to 200, 500, 10 megawatts, 50 megawatts, or let's not even calculate how many megawatts, kind of like you need serious amount of energy that has to be portable, meaning again a solar farm is 2 gigawatt solar farm, but you can't really fly a jumbo jet on that. Even though energy is there, it's just that it's not portable. So that's the issue. Can you make a plane on solar? Yes, there is a plane that has been going around the world, and it's a thing, it's a real. Only thing is that it's hyper slow. To make sure that it has maximum efficiency, the slow, it's like, whoa, it's slow. Meaning this puppy, you're like, hey, this only travels as like 600 kilometer per hour plus. Generally could be 750 also, but like it's above that. Let's just be sure it's above that. That puppy was barely 100. So there is some issue, and be mindful, payload capacity is almost zero. So this has huge payload, that has zero payload. So we need something that has a lot of power and portable. It has to be just like Control C, Control V somewhere. That's the core requirement. And it has to meet certain fuel criteria. Many things can qualify as fuel. Heck, even wood is a fuel and coal is also a fuel. So what does it all has to meet? Well, first it has to be cheap. Why? Our world runs on energy. If base price of energy goes up, fundamentally we starve to death. And I am not exaggerating. Why? Well, think of it this way. Africa has a growing population. How? If it does not have agricultural land where you can grow stuff and all that jazz, how the heck they are eating? Because again, you can't run on photosynthesis and people are not starving there. Of course, some are, but majority are not. If they were starving, they would be dead. So how the heck they are feeding in themselves? They are not. Russia and Ukraine is feeding them. So how the heck did Russia and Ukraine A, grow enough crops, B, ship it across the globe to them? How the heck? Because of these puppies. These puppies are surprisingly energy efficient in terms of how much megajoule it takes to ship, let's say 100 tons of grain from a Russia port or Black Sea to Africa. It's whoa. It's like you will be shocked how efficient these things are. So we need something that is cheap. Fundamentally, it has to be cheap. Otherwise, severe consequences will follow. So it has to be cheap. Then it has to be stable. Now, critical part of stable is STP, as in standard temperature and pressure. Every time you have to tamper with it. For example, if you, let's say, in some fuels, you have to pressurize it to keep it in useful form. For example, LPG. Again, that breaks this puppy as standard pressure and temperature. That's why we prefer liquid fuel. That's the most efficient for our use. Why? Because it's in standard room temperature, as in like sometime as low as, let's say, minus 20 degrees, as high as 70 degrees Celsius. Generally, if you can be liquid in that range, we good. These puppies generally can withstand much higher temperature. Bunker oil, it could require as high as like 130 degrees Celsius to actually become liquid. It's almost like a sludge. So you get the point. Basically, it has to be easy to use in standard temperature and pressure, because every time you have to tamper with it, like either you have to cryogenically cool it or pressurize it, it takes money away. So your cheap part goes away. And it has to be easy. Everything in the whole supply chain has to be just easy. You just like plug it in and don't think too much about it. And again, can you use something complex? Yes. Problem is that complexity will come from the penalty of cheap. So these three things have to be completely there. And safety is good. Aircraft, trucks, and ships. These things are something that if anybody talks to you and is like, I'm going to do this either hydrogen or battery, no. Just no. Can you brute force it? Yes, but you will mess up the cheap part. Or in some scenario, flat out, in case of planes, nobody has been stupid enough where they're like, we're going to drive this with batteries or hydrogen. So that's the requirement. So why does everybody focus on hydrogen so much? Well, if you have watched my channel, I have made a detailed video on hydrogen, why the heck it's one of the worst diseases that we had. It's simply because it does give you one good thing. A, it's a fuel, that's what we want. B, it has no pollutants. If you are using hydrogen directly in fuel cell, you're not gonna get any NOx emission, you're not gonna get any pollutants, no carbon monoxide, everything's good, no sulfur, everything's awesome. That's the good part. But if you have to use hydrogen for, let's say, combustion engine like jet engines or combustion car engines, ICE engines, yeah, at that point in time, you're gonna have NOx and other things also, NOx primarily. So again, it can be controlled, but at that point, people might say, hey, can't you control with diesel? Absolutely you can. So good news, no emission. Bad news, it is very, very, very low energy density. And this is the part where I'm genuinely shocked how uninformed our whole planet is. Like, genuinely shocked how uninformed I is. Like, every Tom, Dick and Harry forgets about, like, fuel has to be made for Earth, meaning in Earth you have pressure, you have atmosphere, you have gravity, it has to work inside it. So what is the most important metric to measure it? Density, as in megajoule per liter. How do we measure fuels for some reason, especially when we are trolling with hydrogen? Galvanometric, meaning megajoule per kilogram. Now to give you a context of that, if I give you this tank, 1 liter tank, how much fuel you can put into it? You will be like, hey, 1 liter. So you will calculate in like how many megajoules I'm going to get 1 liter out of it, right? Your tank cannot be larger than your payload. Tank has to fit inside something. So that's why we always calculate on megajoule per liter. And be mindful when you're talking about something that is pressurized or like it has to be, it also makes shape limited. Petrol tank, which is normal standard temperature and pressure liquid, you can have a tank that is like conforming to bottom of the car chassis and it would be very space efficient while giving you enough space inside. Hydrogen does not have that luxury. It has to be a cylinder, otherwise no. So fundamentally the megajoule per kilogram is the number that nobody shuts up about. It's like 120 megajoule per kilogram. That is factually true. It's just missing a very critical part, that to carry 1 kilogram of hydrogen, to achieve that 120 megajoule of energy, you're gonna need 14 of this, meaning you're gonna need 14 of these puppy to carry equivalent of 1 kilogram of hydrogen. That 120 megajoule per kilogram is 100% useless. To give you some context, so you know what we are talking about, you can look into diesel. What kind of megajoule it has? Like again, in terms of megajoule per kilogram, it's very poor. That's what people don't start up about hydrogen. It's like 3 times more of also. It's very low. It's like barely 45 or something like that. How about the moment you go to megajoule per liter, meaning how much energy this can carry, it becomes 36, one of the highest. It's almost the same as jet fuel. Then you have petrol, gasoline in your places, 32. If you really want to do something stupid, you want to do ammonia, that drops it to 11. If you want to do something weird, CNG, compressed natural gas, that is 9. You go to hydrogen. Now hydrogen, because again, we did try hydrogen for last 30 years, not even 30, last 50 years. Early days, we were trying hydrogen with normal tanks that was like rated for 350 bars. Yes, that's normal for hydrogen. That puppy only had 2 megajoules of energy per liter. Yes, so your tank, not only it has to be super thick to maintain that kind of pressure, it can only carry very little amount of actual energy. So even with 100% efficiency, you're not going to get very far because again, the megajoule is chemically limited. So we increase the pressure to, right now, anytime you're talking about some hydrogen system, generally they are talking at 700 bars. That puppy only has 5.6 megajoule. So what if we liquefy it, right? Rocket fuel, that only has 8. So be mindful, you have 36 and 8. What does this mean? That means at best case scenario, if you take the best engineering and you figured out almost 100% of 8 megajoule dumped into your car wheels, that's a lot efficiency. Here's the deal. Do the same calculation and figure out how much energy efficiency you have to achieve in diesel engines to beat that. Not that high. And be mindful, diesel engines have this weird thing that big ones, really big ones, they're very efficient, like horrifyingly efficient. Like some bunker oil ones are claimed, tested, verified to touch, I'm not joking, I was shocked that this was even possible, 51% efficiency. I did not even know that's even possible. But again, 30% is like, I used to think like 20% is normal. Yeah, day to day, 20%, good. Big engines, big commercial engines designed for efficiency, 30%. You can go higher than that. I did not even know that. Jet engines, even more efficient. So what does that mean? That simply means hydrogen will not give you the megajoules you need to do your work. There is no law of physics that will allow you to breach that part. And that's why, like, you can Google basically energy density calorimetric or energy density megajoule per liter, and you will find all encyclopedia has this graph, all of it. And again, you will like, where is this graph coming from? This graph is coming from Energy Department of USA. Also worked with Department of Defense. They were contracted to figure out what is the alternative fuel model option. So they figured it out, and this is the graph. Everybody never shuts up about like how much megajoule you have in hydrogen. It's just like, bro, how the heck you gonna carry it? You have to carry it in liquid format, which, be mindful, this puppy is so liquid, so cold, that it makes liquid and nitrogen looks hot. Liquid nitrogen is easy to carry. Liquid methane is easy to carry. Liquid hydrogen is not easy to carry. So fundamentally, like your tanker cost going from LNG carrier to LH2 carrier, you would be shocked how much price goes up just because of that, unless the engineers built it for liquid hydrogen itself, which again, sometimes they do. It's like design it for worst case scenario, and they're like, there is no other liquid that is colder than that. So like, that does make sense. But unless it's done specifically for that, yeah, you would be shocked how expensive these puppies are. Like very idiotically expensive. So that's why hydrogen has no tangible use. We knew this from 1970. We'd done this, like we have this, like every school, every engineering college, every engineering handbook. I would not be shocked if they actually have this graph. Again, this is from one vendor. Wikipedia also has this. Every encyclopedia has this. So that's why hydrogen, like people talk about like, we're just gonna carry hydrogen. It's like, how much hydrogen you're gonna carry? Even with 100% efficiency, if you're comparing with petrol engines also, you're not gonna go very far. It's like you can refuel it. So can you refuel with diesel? So what about this stupidity? Well, we have built it. Be mindful, in early days of oil embargo, OPEC did bitch slapping USA, and USA was genuinely considering going boom boom on them, but they were like, dude, that's even more expensive. So there was some issues. They're like, okay, let's use our brain, let's use some brain power to solve it. In that time, they built a fighter jet that's designed for hydrogen. They were actually planning to build a bomber also with hydrogen. This was a test bed project, as in physical craft built physically to fly on liquid hydrogen. Done. We did it. This is Russia. A commercial jet, liquid hydrogen. Done. We got this. And we did all that. You will be shocked how much research and development was poured. Heck, if you watch early videos, you may find from Audi, BMW, both of them have made liquid, not liquid hydrogen, pressurized hydrogen combustion engine cars. Like they made a car and actually sold it, and then they removed it. We have tried it. We did the science, we did everything. And we are like, no, it does not work. Like, that's how we learned. Like, we tried it, we did it, and then we are like, yeah, it does not work. So you may be like, okay, we physically built it. And be mindful, back then it was actually possible. Why? Because that early era of jet engine were not very efficient. Modern jet engines will be bitch slap these things. Why? Be mindful. The megajoule in your tank is the limiting factor. How much you can get out of it, that's another limiting factor of the design. Assuming you can get 100% out of liquid hydrogen, which in a thermal engine you cannot do, but somehow let's magically assume you can do that, your efficiency of modern jet engines, especially jumbo jet engines, yeah, that's very high. And because their tank is so huge in terms of megajoule per liter, it has more than enough number. Do the math yourself. Please do it. It's quite easy. You'll be shocked how, like, hydrogen has to be at least 1.5x more power. Then it may compete. That's assuming you can get 100%, which again, in thermal engine, you cannot. And why it has to be thermal? Look into any design from Airbus, Boeing, or whatever have you. All are thermal designs. They have to be. You cannot carry enough fuel cell to run motors there. So again, can you make fuel cells and motors? Yeah, absolutely. It's just, can you make it light enough to fit inside there? No. So we have built it, but hydrogen is suffering from what we call politicians like this. Why politicians like it? Again, politicians do not have to clear science exam. They do not have to know the difference between megajoule per kilogram versus megajoule per liter. And they like to titillate the public. Whereas like solar roadway, hyperloop, they titillate you. And when they titillate you, you get brain damage. And if they did that, here's the deal. What will engineer do? Because they pass the law. So if somebody in European Union is smoking, I'm gonna titillate the public with hydrogen, they're gonna pass a law that I'm gonna ban hydrocarbon. All hydrocarbon waste vehicle, be it land, sea, or this air, has to be banned. What the hell engineers will do at that point in time? They know, like I'm telling you, 10 years, they have studied this. I can guarantee you, most engineering colleges, especially with aeronautics engineer, they know about these things. They're like, dude, there is a chapter number 12 has this and all that. So they know this better than I do. I will give you 10 problems. They will be like, bro, this is 500-page thesis on this. Why it will not work. They know better than you. But if you force a law, then what the hell they can do? Like, it's not that Boeing engineer does not know. They know better than I do, or every Tom, Dick and Harry else do. But they are forced because of politicians. Why politicians have that power? Because they are titillating you. So they are forcing engineers to waste time on system that we have built and figured it out very early on, that if jet engines became even a bit more efficient, be mindful, this is the early days, so efficiency was horrible. Modern system will be like, bro, why were you smoking so much? Like, why? Flat out. So, and when we look really deeply into hydrogen, everything is just magic. It's like you're just gonna get magical amounts of water. You need insanely large amount of water. Not every place has that. Like, to really replace hydrocarbon one for one, just one for one, we do not have enough distilled water. Then some people will randomly come up with like, what if we extract moisture from the air? It's like, we cannot do that for drinking water. You really think we can do that for fuel? And be mindful, it will break the cheap part of the fuel. So that's why you just magically gonna provide the water for it. Just one half of the equation. Other half of the equation, basically energy, will produce the energy just magically. We'll just magically make surplus of solar panel, magically make ludicrously large surplus of wind farm, just so we can do that. Be mindful, we do not have 100% energy, renewable energy as of now. You only have 10%. Somehow we are gonna expand it so much unnecessarily to produce over energy that can be converted. And be mindful, round trip efficiency, horrible in hydrogen system. Then we're going to transport it somehow. Be mindful, LNG carriers, again, I hope they have been over-engineered to handle liquid hydrogen, but be mindful, even in liquid hydrogen, it's not going to carry that much. So your actual energy that you are carrying in one same ship won't be that much because of the low density. You're going to transport it. Somehow you're going to store it for long duration, somehow, and then you're going to use it somehow. Be mindful, to give you a context, you're going to need 6 megawatts of fuel cell capacity almost to run a normal locomotive. Electrical locomotive. Yeah. Now, can it be done? Yeah, it can be done. It's just that good luck with the price. So somehow you're going to figure out how to use it in things, all of them. Now, is there a possible way? Yes. Metal halide energy storage. Basically, you have a metal powder. Basically, this will be filled with metal powder, halide powders, and hydrogen will diffuse into them. What's the benefit? It will exceed the density of liquid hydrogen. It exceeds that. So it actually makes it useful. So problem solved? Yes and no. Yes, it solves the storage part. It's not portable. Why? Generally the best case, ultra best case scenario was 10% by mass. 10% by weight, sorry, 10% by weight. So if you're carrying 100 kilograms of powder, which, be mindful, will fit inside this, if this was 100 kilogram, only 10 kilogram would be hydrogen. So forget about planes. Has been this used? Yes, submarines use this. Why? Because they need giant ballast to sink. So they're like, instead of just having useless ballast, why not just have metal halide powder, which is, again, acts as an energy storage. So it does make sense in there. And be mindful, some companies that are working with forklifts, they're also looking into it. Why? They need giant counterweight anyway. So might as well have that. And forklifts may be needed to be used in indoor environment. They may be like, hey, win-win scenario. So some scenarios does make sense where you can not worry about the weight penalty. Can it be done with bus and trucks? No. Can you do it? Yes, you can force it. But engineers would be like, dude, it would be just easier to use batteries. Or in case of electric trucks, you can have swappable batteries too, which, be mindful, one Australian company already sorted it out. So it can be done. So hydrogen is suffering from that. Like, politicians are titillating you because somebody tricked them, and because politicians do not have to be held accountable. If they burn your money on solar roadway, they do not need to be held accountable. If they burn your money on basically Hyperloop, they do not need to be held accountable. So if they set you on fire, they do not need to be held accountable. If they are like, what if we do ethanol? I'm like, dude, it will increase your food prices. But they're like, what if we did it? What if we just forced everybody to do it? People will starve to death. Yeah. So that's the stupidity part of it. And that's why I'm like genuinely shocked. I expected this from, like, places that have very poor education, where people will fall for this. Not for smart people where they're like, dude, you built this. You built this. It's a physical thing. You can go into a museum and see it. You can do the calculation. We have this physical thing. This one is modern. So, but again, politicians. So is there a solution? Be mindful, this whole series I have made was very specifically everything that can be done, not something that may be in the future. No, things that can be done. We have one technology, that is seaweed biofuel. Why? It's just solar energy converted into chemical energy. So you are getting solar energy converted into chemical energy. You are putting that in a buffer. Buffer is driving the country. What does this buffer mean? Fuel tanks. Like think about this, like you need to be alive, right? Let's say you are 30 years old. That means you have been eating for 30 years. Is there any farmland that has like that sort of yield? 30 years, no problem? Hell no. Then why the heck you do not go poof? Simply because we have a buffer. All the grains go into the buffers. Buffer feed us. So same thing will be done here. Will we ever have a seaweed farm that is like absolutely perfect all the time? Hell no. But we'll have buffer, exactly like we do right now. So it's just solar energy converted into chemical energy. So how do we have to actually do it? Well, it's just cultivation. The step is surprisingly easy. We have to just cultivate it. And what about the yields? As in like 1 square kilometer, how much you can get out of it? It is exponentially larger than any other crops, be it sugarcane, be it barley, be it jatropha for some reason, be it this or that, whatever. Other than algae, nothing even comes close to it. And algae has serious problem of requiring fresh water. We do not have enough of those. This salty water, it's designed for salt water. It does not even care. So fundamentally speaking, this solves that problem. And I'm genuinely shocked how many people keep falling for that. Like, what if we grow ethanol? I'm like, if you do that, farmers will be incentivized to grow what we call, instead of food crops, they will be instead of fuel crops. That fundamentally means you are going to run out of space for food crops. And that has happened in Brazil. That has happened in America. If you ever wondered, like, why the heck American food prices are going up, look into corn. How much of whole of your America is just growing corn? Like, just look into it. That's why I said, like, basically, politicians do not have to be held accountable. If they designed a bad project, it does not even need to be ended. It's like it could keep running on like fumes for years and decades, and then somebody will wake up. Then they're like, okay, now we have homeless crisis because people can't afford things. It's like, so it's one of those things. Fundamentally, we should not even attempt or even touch that part where you can grow fuel on soil. It has to be grown in sea. So surface area is not an issue. And be mindful, this is actually good for marine life. How? Exactly same way marine life is thriving below wind farms. Why they are thriving? No humans. No fishing boats specifically. Whenever we are growing this in hundreds of kilometers square area, no fishing will be allowed there. Fundamentally, you're going to get multiple fishery life going back again. And it's a natural thing. We are not inventing it. It's there. We're just like, it's like planting forest. So much higher yield, no competition for agricultural land, so people will not starve to death. That's awesome. And we have 1 century of R&D on it, meaning not only the algae part, algae part we have also known for it. Be mindful, right now algae has been grown everywhere. Even in India has like very little growth of like 60,000 ton. So we do grow this. Why? Food companies love this. This is awesome in food industry. Pharmaceutical, India is really good at that. We really keep making this like there is no tomorrow. Every country, like China, is also doing it. So be mindful, we already have this. Like the research and development is already there. And what do you do after you have got the fuel? No problem. Like, how do you ship it? If it's a large volume, we have pipelines. What if it's like small chunks? You can have a train carry it. What if it's like a remote area? You can have a truck carrying it. How do you store it there? We have something known as petrol pumps, gas tanks, gas stations. I think you guys call it gas station for some reason. But is there? Like, it's a thing. India has like what, 40 to 60,000 fuel pumps already done. Like done. We do not have to do anything. We just have to slowly swap up with the fuel. They will not even notice it. Same Indian oil, crude oil plant that is making right now petrol and diesel. They will just receive this seaweed. They will crunch it, and the output is the same. So fundamentally, the research is there. The infrastructure is already done. It's like how we'll do this? It's like, bro, done, sorted. Now, can you fly basically jumbo jet on this? Yeah, it's just a stamp. Why? Because all your one hydrocarbon is same as other hydrocarbon. And if it's not, that means somebody in quality control is messing up. So yeah, yes, there are multiple jumbo jets that have that stamp. Look into it. And it's carbon neutral, not centralized. Now, why the heck Europe is going so much into renewable? Well, to public, they are showing environment. To themselves, they are like, we really do not like the idea that somebody else keeps controlling us. Like, for example, Putin or OPEC. It's like, again, even India has this issue where it's like OPEC decides to like, wing the price, our food prices go up. We do not like that. That's not good. If Putin goes war on them and then price increase, we do not like that. So fundamentally, we want something that is carbon neutral so we can keep doing it forever and non-centralized. That's also an awesome thing. And be mindful, why this can be done infinitely? Because hydrogen is coming from water. Solar energy is causing a divorce between hydrogen and oxygen. Oxygen is eating out of there. Then basically this organic material is consuming carbon dioxide and basically divorcing the oxygen. Oxygen has been rejected, and then they are forcing the marriage of hydrogen and carbon. And we're just gonna eat that part. And after that, this is one core component, we have to dump the biomass back in. If we do not do that, we will deplete that sea. And that's the issue when we are doing algae farming. When we are extracting the whole algae, that area is being depleted. For fuel, we do not need to do that. We just need to take it out, extract the oils, dump the biometer back in. And then we add a little bit of nutrition. Be mindful, all calculations suggest is, again, be mindful, we have been doing this, so it's a known thing, it can be done. How it can be done? We have to just make machines to make it large scale, basically going from agriculture by animals to agriculture by tractors. So this is the solution. So let's come to the wisdom part of it. Well, wisdom is, right now, everybody, you talk to them, they're like, yeah, everything is about that is true, known, science, everything is sorted. It's just expensive. Now here's the deal. Wasn't that same thing true with solar? Wasn't that same thing true with wind? How the heck they changed? They changed because somebody took a leap of faith and invested like there is no tomorrow. That right now we are crying, it's like, hey, our solar panels are 20% efficient. Here's the deal. I just looked into a company. I'm working on a solar panel project. It's like, 20%. I'm like, what if I buy a cheaper one? It was like 16% efficient. Like 16% efficient to 20% efficient. So what does that mean? That simply means the early days it was 10%. Yes. And yet we invested into that. Yet over time, year over year, we kept investing on it, and now we are reaping the rewards. Same thing has to be done with this. And every individual component is known. We know how to build boats. We know how to build farms. We know what to do after you get the crude oil out of it. We know all of that. And yes, you can get crude oil itself if you need to. You can cook it in such a way. That's a known technology. It's a common thing. So everything is there. We just have to invest it. It's like stuck in that loop where it's like, unless you invest into it, it will not become mass produced. If it's not mass produced, the cost will be high. And then people are like, the cost is high. It's like, somebody, especially governments, have to take into it. It's like, it's cheaper than waging a war. It's cheaper than going to OPEC and going to Putin and all that. It's much cheaper. Just trust your scientists, man. Trust your engineers. And India also has the luxury of ludicrously large sea border. Ludicrously large sea border. We guard the area. We don't even need to touch international water. Just national water, we are like, we good. So it's there. And it also can act as a carbon capture. Why? You just overproduce it. It's running on solar energy. You just keep overproducing it, keep milking out the oils out of it, make it into a thicker oil so you can make it, store it much more long term, and then just bury it back again into the ground. Every oil well which we have drained, most of them actually have this architecture there already. It's like we never removed it. It's too expensive. Refurbish it, pump it back in. How do we know it's going to stay there? It was there for thousands of years. We know for a fact. Like, this is as time-tested technology as you're going to get. Make crude oil, dump it back in. Basically, press Control Z on the atmosphere and use solar energy to do it directly. Because again, can you do this sort of thing with this and that? Yes. But why? Why would you want to, like, let's pollute the earth indirectly by making idiotically large amount of solar panel, idiotically large amount of wind farms? It's like, what if you just grow it organically? Like, what if you use nature's automatic tool, natural tool, and just undo it? It's just like, let's undo it. So it can allow us to store hydrocarbons forever, and it does not have that issue where it's like electric vehicles, the battery is genuinely toxic. And I do not mean toxic in terms of CO2, it's toxic in terms of metallurgy. The metallurgy use the mining techniques, it's causing what we call heavy water, basically heavy metal poisoning. And it's sometimes it's going up to groundwater, and that, you do not want to be in that area. So more and more we are doing, because it's happening outside of it. Like, Americans are not thinking about why it's not happening in their land. It's happening somewhere in Africa, sub-Saharan Africa, somewhere in China. So we don't think about it. But again, it's happening here. And if you genuinely want to solve a problem, you want a tool that does not have those sort of things. So out of sight, out of mind is not there. It does not have the issue of EV batteries or the hydrogen, where you just magically gonna overproduce the energy, magically overproduce the water that we need, magically transport it. It's like, all those things can be done. It's like, but why? You spent 1 century of human innovation, research, sweat, blood and tears to make this hydrocarbon ecosystem. Just use it. Just take the fossil fuel, eat the fossil part, replace it with bio, keep going. And be mindful, that's what life does. Like, why the heck you and I can breathe? Simply because we are absorbing oxygen and we are dumping out carbon dioxide. Then why the planet is even alive? Because carbon dioxide being cycled by biology. We just have to increase this part so we can sustain it for long term. And what about emissions? That's a genuine question. Emission will decrease with more R&D. And again, because of the innovation in electric industry, we can take serial hybrid approach, where your vehicle is driven by motors, which is far more efficient and far more torque control. So you do not even need to waste energy in terms of transmission. You have motor, direct drive, and then you have battery. That also gives you the advantage of regenerative braking. So you have a battery that absorbs regeneration, that helps you a lot. Meaning if you are talking about, let's say, a public bus, you could be looking at like every 3 deceleration, you get energy for 1 acceleration for free. So that also allows you to reduce pollution, and because your engine is decoupled from the basically wheels, it can operate at its efficiency band rather than chasing performance where it's like it's like, okay, this is my RPM where I'm the most efficient. And of course it will have active control to like what is the ambient temperature, what is the fuel temperature, all that jazz. It's going to be like, hey, at this RPM I'm going to produce the most amount of energy with the least amount of fuel. That's it. That's the controller will do. And your battery will be the buffer part. So even if you like you want to go on it, the battery is the one, the buffering part basically. And then your fuel part will be far more energy efficient. So actual work done with per liter of fuel would be higher. So we can, that itself will reduce fuel consumption, itself will reduce emission. And emission as in like early 1980s of India was like bad. 1990, some improvement. 2000, some improvement. 2010, bit more improvement. 2020, even more improvement. Now, if you take a 2020s car made in India, take a 1980s car made in India, you'd be shocked how far we have came across. And this is like inside a single lifespan. And same thing will be done in future. We have 1 century of research and development, and engineers are ready. They are ready to go. Just to replace the fossil part, replace it with bio, so it becomes carbon neutral. Most of them can solve it. And be mindful, some companies are also working on fuel cell on hydrocarbon. If that puppy ever works out, problem solved. Emission problem solved. And then again, this also solves the carbon dioxide problem. No problem. So this is what we need to do. We have to be aware of it. Like politicians do not suffer the consequences. They're like, hey, I just passed a law because people wanted hydrogen planes. And every plane engineer would be like, dude, we have built this in 1975, I think. It does not work. Like we tried it, bro. We tried it. We genuinely tried it. We actually built it. We burnt money like there is no tomorrow. But like it does not work, man. But laws. And then that forces companies to use their PR department to give that. And then people will be like, hey, why the heck planes are so slow and more expensive? So that's why we have to be wise about things. And this is a solution. That's why I'm talking about, like, it's not like, oh, it still has emission. Your battery still has emission. Hydrogen still has emission. It's just out of sight, out of mind. You're just not thinking about the emission that you're going to release, making, if let's say 50,000 fuel stations are there for petrol or diesel, you need the same amount for hydrogen also. You're just not thinking about it. So it does not have that out of sight. It's like, hey, we built this infrastructure, just keep using it. So this was my presentation on how to solve the fuel part of global warming. Hopefully you guys have liked it, learned from it. In that case, please give the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I do try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.